So today we're going to continue our talks when it comes to complex numbers, and we're just going to kind of perform some more little operations with those. So we're still on section 2.1, and we can throw a B on there if you want to. And we're just going to continue with complex numbers. So in the last section, or first part of this section, we added, subtracted, multiplied, and we divide some nice little simple kind of complex numbers with introducing those imaginaries. So we're just going to kind of do some more operations when it comes to complex numbers, but our complex numbers might be just slightly more complex. Cute way to think of it. So I got a couple of them here for you. So we'll start with, that's a cute A. We'll start with A. So let's say we have the square root of negative 18 plus the square root of negative 8. So we're going to start with A, and we're just going to go with the square root of negative 18 plus the square root of negative 8. So anytime we want to add our radicals, and on these ones they're imaginaries, they got some complex numbers going on, we always want to, the first thing we want to do is rewrite these so that our square roots of negative numbers are always written in terms of I. So before we go any farther, we're going to rewrite these. So we learned in the previous section that we could actually rewrite this as the square root of negative 1 times the square root of 18. And then our negative square root of 8, we could write it as the square root of negative 1 times the square root of 8. And we know that the square root of negative 1 is I, and we still have our square root of 18. And the square root of negative 1 again is I, and then we have the square root of 8. So now in order to add these two together, unfortunately right now our radicals are not the same number. So like right now we have, I times the square root of 18 and I times the square root of 8. But that square root of 18 and that square root of 8, we can't combine those together unless those radicals are exactly the same, because you're going to ultimately add up how many of those square roots you have. So we need to break this down a little bit. So we're thinking of all of those perfect squares that we remember, all right, to where we know that 2 squared equals 4, right? 3 squared equals 9, 4 squared equals 16, and you can keep going down with those numbers. So when it comes to breaking down our radicals, we're looking for those perfect little squares. So for 18, we still have our I, but then I'm going to break 18 down into the square root of 9 times the square root of 2, because the square root of 9 is a perfect square. And then when it comes to plus, I still have my I, and then my 8, I'm going to break down into the square root of 4 times the square root of 2. So now I can just continue to simplify this. I know that my square root of 9 is going to give me 3. And if we want, here we can do I times 3 times the square root of 2 plus, we still have our I, square root of 4 is 2, and we have our square root of 2. Usually we try to write, the real number first and then the imaginary. So I'm just going to write this as 3i times the square root of 2 plus 2i times the square root of 2. Maybe to help kind of put things in order. So now our radical are exactly the same. They're square root of 2's. So how many square root of 2's do I have in total? Well, this is telling me I have 3i square roots of 2's, and this is telling me I have 2i square root of 2's. So I'm just going to add those together. 3i's and 2i's are going to give me 5i's square root of 2. Not too bad. So a little bit of how the last section when we multiplied, we're going to do another multiplication. So for b, let's say they gave us -1 plus the square root of -5, and all of that is being squared. So again, like the first thing I'm going to do is I want to make sure that I am expressing all of my square roots of negative numbers in terms of I. So I don't want to leave it as that square root of -5. I want to factor out that I. So as we become more proficient with writing out our i's, we might be able to jump right into writing this as -1 plus I times the square root of 5, and that is still all squared. And since it's squared, we can separate those factors and write it out twice. So that would be, whoop, forgot my negative. -1 plus I times the square root of 5 times -1 plus I times the square root of 5, right? Because it's being squared. So squaring it is you're multiplying both of those. You're multiplying two of those together. So once we get to this point, you can either use the FOIL/distribution method, or we can use the area model. And I'm just going to go ahead and use the area model. So we got a nice little box. And then I'm going to go with what? -1 I times the square root of 5, and then -1 I square root of 5. So now we're just going to multiply those, figure out the area of each one of those little rectangles. So -1 times -1 is going to give me 1. -1 times I times the square root of 5 is just going to give me -I square root of 5. Same thing's going to happen here. -I square root of 5. And then now I'm going to get I times I is I squared times the square root of 5 times 5 is 25. Right? And then I'm just going to write it all out, nice longish way, right? So I got 1, and then I'm going to look for those like terms, and hey, I got a square root of 5 and a square root of 5, so I know I can combine those. So -I square root of 5 minus I square root of 5 is going to give me 2I square roots of 5 plus I squared times the square root of 25. Right? So now we can just kind of work on, we recall the fact that we know that I squared always equals -1. Right? So we can keep going and simplifying this problem. So we got 1 minus 2I square root of 5 plus I squared we know is -1, and the square root of 25 we know is 5. So we got what, 1 minus 2I square root of 5 minus 5. So just simplifying some of our terms, we would end up with -4 minus 2I square root of 5. Now we have our real part. So our real is the -4. And then our imaginary part is that -2I square root of 5. Alright. So let's look at a little bit different than the last multiplication or division problem that we looked at on the previous, on 2.1a. This one's going to be written a little bit different. So let's say we had 25 plus the square root of -50 all over 15. So there's a little pattern going on here, right? So the first thing we want to do is express all of our square roots of negative numbers in terms of I. So I'm looking at this negative square, or the square root of negative 50, and I know that that's an imaginary number, so I want to make sure I'm rewriting that in terms of I. So I'm going to rewrite it as, what do I got? Negative 25 plus I times the square root of 50 all over 15. So now when I look at the square root of 50, I'm looking and asking myself, can I simplify that down? Is there any perfect squares that go into that evenly? And I'm going to say, yeah. I think I can break that down into the square root of 25 times the square root of 2, right? So I have my negative 25 plus I, and then I'm going to break 50 down. I'm looking for those perfect squares, and I know that 25 is a perfect square, right? Square root of 25 is going to give me 5 times the square root of 2 all over 15. So now I'm just continuing to plug and chug on my math and simplify this down a little farther. So negative 25 plus, and I'm just going to put my real number out front. I know that that square root of 25 is 5. I still have my I and the square root of 2 all over 15. Thought of a joke. I'm like, I still have my I, right? So I can still see. All right. So we're getting someplace and we're doing really good. But when it comes to fractions, we always want to make sure that our fractions are reduced as far as possible. It just makes life a little easier in the long run. So when it comes to reducing fractions, the way that this is written, this is technically two fractions that we're just writing under a common denominator of 15. So when I want to be able to reduce these, it's the same thing like when it came to adding, subtracting, multiplying, well, adding and subtracting, right? Real numbers to real numbers, radicals to radicals, right? Reals to reals, imaginaries to imaginaries. That all kind of applies. So when I look at these, if I'm wanting to reduce out of my denominator is a real number. So I can only reduce this guy with real numbers, which are these three. So I have to be able to reduce it out of all three of those to reduce my fraction. So the mistake that gets made a lot of times is we reduce it out of one part and we don't do it out of the other part. So to help eliminate that, I think it's best if we write this as two fractions. So I'm going to write it as negative 25 over 15 plus 5i times the square root of 2 over 15. Now I think it's easier for me to be able to reduce this. So now I'm looking at my negative 25 over 15. I know that 5 is going to go into both of those. So that's going to reduce down to what? Negative 5/3 plus reals to reals, right? So reals to reals. So this is my only real part. So 5 over 15 is going to give me, if you want, you can put the 1 on there, right? 1 over 3, and we still have our I times the square root of 2, right? So if you like ones, you can keep that 1 there by all means, or you can just write it as negative 5/3 plus I times the square root of 2 over 3. Right. And yes, technically, like that 2 is a real number. That square root of 2 is a real number. I guess I should have said like whole number to whole number when it came to reducing. All right. So the nice part about this is if we go way back in the day, there was these cute little things, this cute little formula called the quadratic formula, right? The quadratic formula. And we love the quadratic formula. We can use the quadratic formula to solve quadratics, right? So we all remember this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you guys can get on YouTube and find some cute little videos of some songs on this. Maybe in your spare time you guys can put together a quadratic formula song, and you guys can splice it all together and, you know, TikTok it. Be a sensation. Be the quadratic formula TikTok sensation. Right? All right. So I think we know how to solve these. Well, we're going to try it anyways, right? So we're going to solve using the quadratic formula. So let's say we had this function 3x squared minus 2x plus 4 equaled 0. So granted, we could always try and factor this. And if we're going to factor it, 3 times 4 is 12, right? So you're looking for multiples that are going to get you 12, or factors that are going to get you 12 with the difference of -2. And I don't think it's going to work, right? So we can't factor it. So a lot of times, that was even back in Algebra 2, we would look at these problems and we'd be like, okay, so how can I factor them to solve them? And if I can't factor them, then I'm going to use the quadratic. But if I can factor them, I'm going to factor them. So this one we can't factor, so we're going to go ahead and plug this into our quadratic formula, right? And just a quick review, our a is going to equal 3, right? Our b is going to equal -2, and our c is going to equal 4. So when we go to plug that into our quadratic formula, x is going to equal -b, so -b is going to give us 2, plus or minus the square root of b squared, so -2 squared is going to give us 4, right? That first term right there, that b squared, should always become a positive number because you are squaring it. So this first number will always be positive. Minus 4, we're going to do it this way, 4 times a. 4 times a is 12. 12 times 4 is 48. So minus 48 all over 2a, so 2 times 3 is 6. So now we're just going to simplify this down. 2 plus or minus the square root of 4 minus 48 is going to give us -44 all over 6. So back in the day when we were in Algebra 2, we're like, oh, no, no solution, can't do it, moving on to the next problem. So ultimately what this tells us, when we have that negative or that imaginary under that imaginary number within that radical, it's telling us that our solution is imaginary. So if we go back to when it came to our quadratics, and when we were solving quadratics, we were looking for those x values. So we were looking for 1 or 2 x values, so then we could draw our parabola, right? Or it might have, well, I guess this one's positive, so it would have gone this way, right? Well, now when it comes to our parabola, it is really like a no solution. It has an imaginary solution, which means that it's not crossing over the x-axis. It's up here someplace, right? But we can figure out what those imaginary roots are. So first thing we always do, we have to make sure that we're expressing our square roots of negatives in terms of I. Okay? So this is going to give us 2 plus or minus I times the square root of 44 all over 6. I'm looking at that square root of 44 to see if there's a way that I can simplify that down, that I can break it down. I'm looking for those perfect squares, and I'm going to come up with 2 plus or minus I, and I'm going to break 44 down into the square root of 4 times the square root of 11, and that's all over 6. Ooh, I'm going to run out a little bit of room here. We're going to squeeze that up. So I'm just going to do some algebra and keep reducing, right? So 2 plus or minus the square root of 4 is 2. Still got my I, and then the square root of 11 all over 6. Right? And then I'm going to look at that square root of 11, and I'm going to go, is there any perfect squares that go into there? I'm going to say nope. And then I'm going to separate these fractions. So I'm going to have 2 over 6 plus or minus 2i times the square root of 11 over 6. 2 over 6 is going to reduce down to 1/3 plus or minus. That 2/6 is going to reduce down to 1/3 again, and then I'm going to have an I times the square root of 11. So there's my two imaginary solutions to that quadratic formula. How fancy! Sometimes they will give you, just real quick, they'll give you a quadratic and they'll write it as, let's say, like 3x squared equals 4x minus 6. And in order to put that into that quadratic formula, you need to know your a, your b, and your c. So it has to be in that standard form. Standard form is ax squared plus bx plus c equals 0. So we just got to move everything over. Move everything over to the left, right? So you would have 3x squared minus 4x plus 6 equals 0. And then now you know your a, your b, and your c. Oops, that's a b and your c in order to put it into your quadratic formula. All right. That's all I got for you. Hop on over to the website and there's a handful of problems. I think it's like 29 to 49 odd, I believe. So I'm here all hour if you need me.